Hey everyone, so today this video is about our assignment 2, that's driverless car pathfinder, and it's all about graph-based path planning algorithms. So let's see the code that we came up with. So my name is Shubham Rishi. So as you can see, like this is from one place on one point to another. Here I'm using radius of Earth, which is used to check the consistency of the code in A-star algorithm. For the value of y, I'm using rand range, in which I'm getting a random number from range 5 to 10. Here this is user interface, in which we can select the cities. In this we have like 4 cities that we can select in vice versa state, like from anywhere to anywhere. Now in this long and latitude method, it is used to measure the arc so that I can see like the A-star code is consistent or not. Here I have like longitude and latitude values of the cities, and then I'm using this to measure the distance from one point to another so that we can know what's the arc distance. Now, as we go further, we have like Raspberry algorithm. This is like shortest path. So in here, I'm taking two paths. The shortest one will be sorted out by itself. Now, as we go, the main algorithm is A star, in which I'm taking two paths. Here, this is the line that's gonna check my consistency and admissibility, in which the arc value should be less than the path, and the heuristic should be less than the path for admissibility and consistency. Here I'm calculating the total points, the score of the A star value. So for one value and the second value, in which I'm adding the path one distance or cost to with the heuristic cost. Same goes with the second one, and now as we all know, like the lesser the cost, better the path, or more optimal. So here I'm checking which one is more optimal, as well as to know why it's optimal. I'm using a round function to round it to 2 decimal places and measuring the score in which I'm getting it from here. So after that, it's gonna give us the optimal value of X that got selected. And to make it more consistent, I have if and else statement, which like if it's not consistent or admissible, it's gonna take a new value of y, and then we redo the A star algorithm to get the consistent value, the optimal value and consistent. Yeah. So now this is Pathfinder, in which I have paths. I could also say the nodes from one point to another. Here I have algorithms, so the algorithm takes a path and then passes it to the algorithm that we have in here, and it do the whole stuff. So now we have Dijkstra's algorithm. This is the shortest cost, and get the path with the shortest cost. Now this is the heuristic value calculator, in which we will it's up to the user interface that we select, and then we'll get the value of x, and then we'll get x minus y, which is our heuristic score. I'm rounding it to 2 decimal places to make it more easier to understand. And here are the functions how it is. So let's see how the code works. Let's take the city AB, Abbotsford, and Chilliwack CH. Now let's see. So the value of y is 9. It's a random value. Our heuristic score is 22.5. After that, we can add x2. This is x minus y. And after this, we have like the least cost using Dijkstra's algorithm is 31.5. Our result of the straight line, the one that I'm seeing like the arc, is 26.86. It's just to like know what's the value. It's not needed to demonstrate it here. Now using Grasshopper, our path, our selected path is 31.5, and now the optimal path as per A star is with the score of 54, and the path length is 31.5 kilometers, whereas the path that was defeated by this got a score of 55.2 because it has a distance of 32.7. We can select different cities to check like, yeah, the code works perfectly, like Surrey, and let's take Abbotsford. So yeah, the value of y is 8 this time. The heuristic value score, the path selected by the algorithms. This is our optimal path because like the score is 80 with the kilometers of 44 kilometer. We got path 2 this time. And the score that got defeated had a score of 80.6, whereas this one had 80, so it won by zero point 0.6 only, and the the path which wasn't selected is 44.6. The code is very clear to understand. I have four cities we can select from anywhere to anywhere, so it's easier. It works perfect too. I hope so. Like this much is enough to make it understandable, and the code is pretty much clear to understand. Thank you very much to patiently watching the video. I hope so that this is the code that was required for the assignment, and I'll get pretty good marks for it. Thank you very much again. Have a good one.